Hello and welcome to Varsity Eco. Today we are going to study the first chapter of microeconomic theory, which is the cardinal utility theory. Okay, so in this class, first of all, we are going to discuss the term cardinality itself, because as far as I understand, there is a lot of misconception around this term. Then we will move to the model itself. And like any model of microeconomics, it will have some assumptions. In these assumptions, we will also study the form of utility function, because there is a huge literature actually on this. Okay. Then we'll go to the analysis of the equilibrium. In this analysis, we have some parts. First, the law of diminishing marginal utility, the law of diminishing MU. Then, the equilibrium itself for single commodity and multiple commodity. We will solve a problem involving two commodities to understand how this problem is solved. And related to this, the most famous principle actually of utility theory is the Equi-marginal principle. And as it happens, this principle helps us in the derivation of the demand curve. So derivation of demand curve. And Equi-marginal principle is one thing which remained intact in ordinal utility theory also. Okay, so in that way it is very important. Then we have the criticisms. Okay, and these criticisms actually will talk about why we moved from cardinal to ordinal. So a great question on that regard is, what are the points that remained intact and what are the points that actually changed, and if changed, why did it change? And also in current economics, there are some parts where we still use cardinal utility theory and not ordinal. Okay, then we have a little bit extra, the famous idea of consumer surplus, the idea which is developed by Dupuit. We'll talk about the problem he chose to solve and gave us the idea. And remember, when Dupuit did this, we didn't have the modern definition of consumer surplus. He didn't actually know that he was doing something which the way we know it today. Okay, and that's the beauty. And then we have a mathematical note for the inspired and advanced student. In this mathematical note, one of the important tasks is we are going to view the cardinal utility from the point of view of ordinal utility. So this will be appropriate actually for somebody who has studied ordinal utility theory already, and then looking at the cardinal utility theory. Okay, so in the next section, we'll start the class following this format. Now, before we even begin, let us clarify one thing, that the theory of utility, or utility theories, so to say, this is not theory of demand. Okay, because most of the students have this idea, as we derive demand curve just after discussing utility and budget, they think that they are same, or at least one is a part of another and that kind of thing. Now, the part concept is acceptable to a certain extent, but these two theories are not same. Why? So if you go back to the history of this subject, Then utility theory roughly obviously starts with the famous Adam Smith, and it starts with 1776, the publication of an inquiry into the nature and causes of wealth of nations. And it ends, if we can say it like that, with Slutsky. If you have studied ordinal utility, then you know this name, and to approximately we can say 1915. Okay. Now, Adam Smith in his book gave two ideas regarding a commodity. One is value in use and the other is value in exchange. Right? So if you have taken economics as your high school subject, then also you know these two phrases. Value in use is something that generated the theory of utility, and value in exchange goes to the theory of demand. Obviously they are connected, but they are not the same. So with this clear in our head, we now understand that we are currently studying the cardinal utility theory. Okay, and then we'll eventually come to the demand. Alright, so the word cardinality first came to us in mathematics, precisely in set theory. Right? In middle school, we all solved a question, and the question is the cardinality of a finite set. Now, what do you mean by that? We mean essentially the size of the set, and if we explain it, then the question is how many elements are there in a set, in a specific set actually. Right? That's what it did. And the answer is the cardinality. Now, we may think that, what is it? It's just a simple counting, right? But even in that counting, if you look at the mathematics that is involved, it is something like this. You have got a set of objects which can be real or abstract, and there is a certain set of natural numbers, right? The numbers that helps us in counting. So in terms of advanced mathematics, actually, this is what we are doing. We have a set of objects. Somebody asked us what is the cardinality. We have a set of natural numbers. Obviously, there's an infinite set. But since we are talking about finite set, we take a subset of that natural number, and what we do is a one-to-one mapping. So one object, a second different object, distinct object, right? And then it goes to 2, and we proceed in that. Now, in economics here, we are actually trying to do the same thing. So we have a set of non-numeric objects. Okay. And then we want to transfer it to a set of numeric objects. Okay. In simple language, we want to assign numbers. But obviously, counting will not do the job. Why? Because we want to introduce the concept of utility, the value in use. So the basic question then that we have to solve in order to have this is, what is utility? And you have studied a lot of definitions, I understand that. In some definition it's the satisfaction that we derive, probably by eating or wearing a shirt or using this digital media. But then eventually problems started coming up, right? And today we consider this term as a tautology. That's what he's saying. And Samuelson is behind this meaning. He said that all these subjective words or comments or adjectives they are not appropriate. Let us simply say that utility is something that a consumer maximizes, and what a consumer maximizes is her utility. Alright, so it's a circular thing, that's why it's a tautology. But in the days of cardinal utility theory, that was not really the case. Okay, so we will come to that, but we will deal with them in the section of assumptions. But we must clarify that if we want to build a model, then what we need? We need, especially speaking, strictly speaking, we need typically two things. So we need a unit of measurement, because simple counting will not do. For that, the term came utils, right? And then we need to build a connection, a mapping, right? Which will eventually lead to, obviously, the utility function. So we will talk about its form again in the assumption. And the third thing is this: what is utility? That is, we need an objective concept of utility. So now we are into assumptions, and we are going to write actually a lot of things. You can take note if you want. I will not say that if somebody asks a question on these assumptions, you write the whole thing as I am writing. You must take a crux of the material and write them. Okay? Alright, so the first assumption: utility of each commodity is a cardinal measure. The unit of measurement is utils. Utils. Okay. The cardinality, and this is, you must remember this part, the cardinality implies that differences of utilities matter, and such differences will have the same meaning regardless of where or to what the scale is being applied. Now, what do we mean by that? We mean that if we are talking about a gap of 105 minus 100, or we are talking about 15 minus 10, then this value 5, these two 5s are same. That's what we are saying. Okay. Also, this 5 will carry the same meaning whether we are talking about utility of food or clothing or houses or cars, it doesn't matter. Okay. So regardless of where or to what the scale is being applied. In case of value in exchange, the utility is measured by the monetary units that consumer is prepared to pay for another unit of the commodity. Now, we are accepting that utility is a psychological issue, but we are trying to build an objective concept around it. In this setup, we must name Jeremy Bentham, who actually worked out 4 dimensions of utility and then 32 different circumstances. Okay? And he actually said that the pleasure produced by the possession of money is as the quantity of money that produces it. So, in a much simpler word, the last part, that the utility is measured by the monetary unit, so on and so forth. Okay? Alright, so now we'll move on to the second assumption. The second one is the form of utility function. This is vital because changing this form is one of the reasons that today we study ordinal utility theory. Form of utility functions. Utility of one good is independent of utility enjoyed by the consumption of another good. So essentially there is no relationship. That's what we are saying here. Hence, utilities are additively separable. Additively separable. So if you are coming after studying ordinary utility theory, then you know that this is basically a special case. That is, u of x1, x2, xn equal to u1 x1, u2 of x2 plus plus un of xn. Sum over I runs from 1 to n, uy xi. Okay. N is the number of commodities here. Now there are 2 more concepts related to it. So number 1 is total utility. It is the utility derived from total number of units of a commodity consumed. Basically, you put the value of x in this u1 x1 or u2 x2 function and you get the total utility. Symbolically, TUN, this n means that you have consumed up to n number of x1 good. So this will be equal to u1 of x1 equal to n if we are looking for x1. If for x2, then similarly we can proceed. Okay, let's say this is 1. Number 2 is marginal utility. So MU I, let's say, that is ith commodities marginal utility. So this will be basically the total utility obtained from consumption of n number of commodities and n minus 1. So that is very simple. And in today's world, we should write dTu dxi, or we can also write dYxi dxi. Okay. So we know that this is basically the incremental utility of consume one additional unit, right? Okay. Alright. Now these two concepts of TU and MU, they are brought in again by Dupuit. Okay. In 1844, and as we know, he is the same person who also came up with the idea of consumer surplus, although in a different format. But the interesting point here is that this additively separable form is also supported by Alfred Marshall. Okay. And as I said, that eventually when this function changes to something different, we came to the world of ordinal utility. Okay. Now, the implication of these assumptions. These two assumptions together implies two things. The implications, one, and this is the most famous one, that interpersonal comparison of utility is possible, and this is still used in the construction of social welfare function. Okay. And number 2 is for the same individual, MU, that is marginal utility, at one level of consumption can be compared to MU at another level. Okay. Now, assumption number 3. Marginal utility of money is constant. Okay, now there is a separate line of literature regarding how we should consider the utility of money and not money itself, right? And we are not going into the details of that. If you are interested, you can always check the video on uncertainty. There we have talked a little bit that people don't really bother about the monetary level, rather they associate their decision with the marginal utility of money. But here, money plays a very important role, and that role is that money plays the role of measuring rod. So that is why marginal utility of money has to be constant, because if your measuring rod itself changes, if your idea of 1 meter itself changes, then you cannot measure any length at all, right? So this is that assumption. So we are going to write that this is necessary if we wish to measure or we wish to use monetary units as the measure of utility in exchange. And number 4, last but not the least, rationality. In the future classes of ordinal utility theory, we will discuss a concrete definition of rationality, what it means to be rational in an algebraic sense, in a mathematical sense. But here we use the everyday meaning that we have in our subject. So the consumer is rational in the sense that she is a utility maximizer. Now, we talked about Dupuit and Mas-Colell, obviously, about our aerospace, but these assumptions, they were not in this form when they started working. They were later formalized by 3 economists, we should name them, Jevons, Menger, and our famous Walras, and they did it around 1870s. Because of that, in many reference books or reference texts on cardinal utility theory, basically mentions the name of these 3 persons. Okay, so now in the next section we will move on to the analysis of the model. Although we have talked a lot about the additive separability character of our utility function, we have not said anything about its shape. However, in order to analyze the model, this is the point where we should start. So, behavior of total utility. Behavior of total utility. Okay. The initial utility, that is what we can say derived from first unit of consumption. The initial utility is positive. Then, up to a certain point, the more units of a commodity is consumed, the greater will be the total utility at some point. Total utility reaches its maximum point, and for our continuation of microeconomics classes in future, we will insert the name saturation point, because again, if you are coming from ordinal utility, then you know that there is something called a bliss point, although that is defined for obviously at least two commodity. Anyways, so beyond that, total utility reduces. All right. So if you were to draw the diagram, it will simply look like this. So initial utility, okay, so this is our x, u of x. Our initial utility is positive. So let's say this is our utility of the first unit. Then it goes higher, reaches a maximum and reduces. Right. So if you know a little bit of calculus, then you know that this tangent is a horizontal line, and we will refer this as the saturation point of x. And if we go by differentiation, if we draw the mu, then the mu will go like this, just to be exact. So it will intersect the horizontal axis at this specific point, and we have called it the saturation point. Now, who guarantees that, right? Nobody, because this is our construction. But from our everyday experience, we have enough justification for that, but that will not how we should progress. So, law of diminishing mu, something that guarantees the shape. So what is this law? Each additional unit consumed of a commodity provides less additional utility to the consumer. Okay. Now, in future, I will ask you to remember the role of this law, because in future, when we will be talking about the law of diminishing MRS in the ordinal utility theory class, we will also prove a result, which is that diminishing mu is neither necessary nor sufficient for diminishing MRS. Okay, and there we will complete our journey in the sense that you will understand that this has no connection with ordinal utility theories, IC being convex to the origin and diminishing MRS. All right. Okay. So our utility function, u dot, let's say, okay, is a strictly concave function of consumption levels. To be mathematically correct, we should mention that, right? Of consumption levels. Okay. And theoretically also, there are two exceptions which are not important actually if you are in college, but if you are in high school, then these exceptions are important. They are commodities of exceptions. So commodities with small initial units. something like drinking water. Okay, and number 2 is rare commodities or antiques. Let's say picture or a painting or an old photograph, that kind of thing. Okay. All right. Now a very important note again related to this shape. Note that with the additive setup, diminishing MU is sufficient for convexity of IC in difference curve in a multi-commodity setup. Because in ordinal utility, we are and we will and we can talk only in terms of a single commodity. So in this sentence, this is a very important point. Alright? Because otherwise, as I said, that we will be proving a result where we will show that diminishing MU is neither necessary nor sufficient for diminishing MRS. In the equilibrium, we will first start with single commodity. Now we are in a marginalist setup, which essentially means that we will go to the last unit, we will judge in the margin, and we will basically calculate what we are gaining and what we are paying or sacrificing, and we will stop at a point at that unit where these two are same. Okay, and we will go proceed by one additional unit, that is the marginal thinking. Okay, so given prices, or price actually, single commodity, so given price and income, the consumer derives MUX from the additional unit, and at the rate of price, say Px. Okay, so obviously at equilibrium MUX equal to Px, the central result of this model. Okay, now actually this result, originally this result should look like this: MUX equal to Px into MUM. Okay, where this MUM is basically marginal utility of money, and we should write like this because that makes the comparison more logical. It's like for 1 unit of money, this is the amount of utility or marginal utility that you are losing. So if the price is Px, so that much unit of money, so that much unit of marginal utility for the last unit of money, and this is the marginal utility. So it is a comparison between two utilities actually, right? One is for one and y is gained. So from here to here we have a hidden assumption, that is normalizing MUM equal to 1, because we have assumed it to be constant, right? Alright, so what is the basic rule then? The rule is MUX greater than PX implies by more, and MUX less than PX implies by less. Okay, if we go by a very small diagram, so here is our x, and in the last diagram we have seen, so let's make it simple. Let's say this is our MUX and this is our PX, which is given, so it's a PX star, and for that we consume X star, and this becomes our equilibrium A star. Okay, now this was first provided by Gaussian, whose name is not really taken nowadays much, in 1854, and as I took three names at the end, just a bit before, later it was formalized by Jevons. Okay, and Gaussian's version more connects to this equality condition. What Gaussian wrote is basically that MUX is MDUL. So what is this MDUL? MDUL is marginal disutility of labor. Nowadays we don't use this kind of phrases in economics, but in future, one fine day, if you being very enthusiastic, open general theory written by Keynes, you will see this phrase of disutility of labor coming in, because that was the literature then. Okay. All right. So now we'll move on to the multi-commodity setup, where we'll take essentially two commodities, and we will reach a result which will stay same going from cardinal to ordinal. So B, multi-commodity model. Our thinking remains same. Assume two goods, we are on the margin. So money is being spent on two goods. That's what it essentially means. So essentially I have two choices. Now, given our knowledge of single commodity model, what it tells is that we must spend the money on that good which provides us with higher MU. So this is exactly what we are going to write. That additional unit will be spent on that commodity for which MU derived is higher. Okay? And remember, we have assumed that our utility function is such that the utilities derived from these two goods are independent of one another, right? So that means I don't have to think of what is happening to the utility obtained from the other good when I'm spending more on the first good, let's say, for example. Okay? So this gives us the equilibrium condition. So on the margin, obviously, so hence at equilibrium, where shall we stop? We will stop at a point where the MUs are equal for the last unit. So at equilibrium, last unit of money spent on each commodity will bring same MU. Okay. So given commodities X and Y, prices PX and PY, and income M, obviously individually they mean that this is true, right? This has to be true, and from that what we get is this. And if we take away this MUN, which is a constant, obviously, what we get in general is that for n commodities, we'll write as 1, 2. So mu1 by p1 equal to mu2 by p2 equal to dot mun by pn. And this here is our famous Equi-marginal principle. So let us formally write it, because this is one principle which will stay same and will be quite useful in ordinal utility theory, majorly in places where our famous Lagrangian method will not work, which are obviously the more interesting cases. So the utility derived from spending an additional unit of money must be same for all commodities. Okay. So here then what is the rule? The rule is this: if mu1 by p1 is higher than mu2 by p2, then according to the diminishing nature of mu, or just because if it is higher, buy more x1, right? And the diminishing nature actually bring in the equality. And obviously, if the opposite is true, then just buy more x2. And this is the structure which is really helpful in problem solving in future, where we have, let's say, the case of perfect substitute, perfect complement, and so on and so forth. Okay. Now, this is only for those who have studied a little bit of mathematical in UG by now. We also know that if we solve the Lagrangian problem and if we use a little bit of duality, what we can show is that in this Lagrangian structure, in this Lagrangian structure, this lambda is nothing but marginal utility of money. And if we look at this rule, Equi-marginal principle, it is also saying the same thing, that this is true. Okay, because if you differentiate it, you know the details, right? And we will work on the details, but obviously not in this class. I'm just referring it to understand that this is something which is here also, but in a very different format, under a very different construction. The central result though stayed the same. Alright. So now we are going to take a numerical example to really understand that when there are multiple commodities, how should we proceed? Because it will be not like this. And we have really not discussed that how budget constraint will be satisfied. So this is the numerical example that we are going to discuss. It's a pretty easy one. Income is 5, prices of the commodities are same, rupee 1. These are the 5 units, and this is how the marginal utilities of X and Y changes as you go along. Alright. So because Px and Py both are 1, so essentially at equilibrium, all you have to ensure is that mu1 is equal to mu2. That's what we need. Okay, now if we go step by step, then when you have the first unit of money, you have 5 units of money, right? So when you have the first unit, who will you go for? You will go for, so first unit that you will buy is X, right? And why is that? Because the 12 is greater than 9. Okay, alright, so we can just proceed. So 12, then for the second unit again, at the margin 10 is higher than 9, so X again, 10 is greater than 9. Now if you go to the third unit of X, then the mu you get by using 1 rupee is 8, but here if you buy Y, it will become 9, so obviously then again mu on the second commodity becomes higher. So the third unit that you will buy is Y, because 9 is greater than 8, alright? And then for the next amount, the fourth unit, again you have 8 and you have 8 and you have 8 here also. So at this point they are same. But if you buy each of X and Y, then fourth and fifth, 1 unit of X and 1 of Y. So essentially your money is exhausted now. So money is exhausted, right? By that we mean that this is satisfied, P1x1 plus P2x2 equal to M, and at optimal your x1 star will be 3, and okay, we are using X and Y, sorry, so X and Y, so this will be Px and Py, yes, yes. So X star will be 3 and Y star will be 2, given prices are 1, obviously M is equal to 5. Okay, so in the next section we will proceed to the derivation of the demand curve, which is obviously the target of this chapter. The derivation of demand curve here is very straightforward, but for multi-commodity setup it has a very important implication. We will talk about that here. So the derivation has basically two parts. So on one hand, we have this law of diminishing MU, which essentially says that MU diminishes with rise in consumption of X. And on the other hand, we have that at equilibrium, MUX is equal to PX. Now, if we combine these two, we basically get the demand curve. And the fun part is that the demand, or rather, we should write that the quantity demanded of X following this must be associated with a decrease in Px. Otherwise, this whole structure becomes quite impossible actually. So that means that mu is equal to Px at the choice, the X that you are actually buying for that. And again, mu is downward sloping and the quantity demanded of X must be associated with the decrease in Px. So in a sense, what it means is that in the diagram, our old marginal utility curve becomes our new demand curve with a little bit of qualification. So this is our demand curve of X. So we can have it MUX PX. The only qualification is that in case of demand curve, we do not draw that part of MU curve which is below the horizontal line. That is because it doesn't make any economic sense. So from here, we should write two results. And result number one is that MUX becomes the demand curve except the part where MUX is negative. And result 2 is our famous law of demand, which states that the demand curve is downward sloping. Right. Okay. Now, one important thing is that this demand curve that we have drawn here is called the inverse demand curve. And when you will be studying the market morphology, mainly monopoly and oligopoly, there this inverse demand curve will be really important, which is basically what we have drawn here. That is P equal to P of X with P dash X less than 0. And the opposite of this is the direct demand curve, which is X equal to X of P with X dash P less than 0. So now probably you have the answer to this culture of ours where we write X here and P here, but mathematically, so to say, we should have written the other way. Okay. So now in a multi-commodity setup, what is the idea? The idea is pretty simple. Just use the Equi-marginal principle and show the shape of the demand curve. That's it. Okay. So with additive utility function, the following result is an implication of Equi-marginal principle. So what is the result? The result is that the demand curve is downward sloping. Okay, so this is the result. Now how? So the principle says that this should hold for any number of commodities. So this holds. Now going by demand curve, so to derive it, assume P1 decreases. So what will it mean? It will mean that MU1 by P1 will rise in comparison to everybody, in comparison to the rest of this equality. Then again, this implies y would 1 more. Alright? So, the result. And this result holds for each of the commodity in this equi-marginal principle. So, demand curve for each product, commodity, good, whatever you like, must have a negative slope. Now all that is good, but the problem of this result is that this means in a multi-commodity setup there is no chance of a given good. That is why, looking from cardinal utility theory, the existence of given good is a paradox. Okay. So we'll just, to finish this section, we'll just read out what Walras said. So Walras stated that it is the amount of income and not its composition in terms of goods that influences consumer behavior. An increase in income will lead to increased purchases of every commodity. So we'll just write down the last line. An increase in income will lead to increased purchases of every commodity. Again, coming from ordinal utility theory, if you have studied ordinal utility theory, you know that this is not true at all. Okay, so before we go into criticism, we will take a look at consumer surplus in the next section. As I stated, that the credit goes to Dupuit. Now we are going to discuss the consumer surplus idea as given by Dupuit under this cardinal utility theory setup, which means that not only utilities are cardinal, but also there exists interpersonal comparison of utility. Now, Dupuit was not, as I have said, working on consumer surplus, so to say. He was working on a different problem. The problem is to tax people according to the benefits received by a public good. And if you have studied a little bit of social welfare function, you know how to solve such a problem. The assumption of interpersonal comparability can help. Dupuit, as I have said, distinguished MU and T. His definition was actually based on that. So, consumer surplus according to Dupuit is equal to excess of TU over MU into number of units of commodities. Okay. Now, at equilibrium, MUX equal to PX, and if we integrate over MU, then what we get, let's say MU dx, we get TU. We will include these two eventually and show that it will give the modern definition of consumer surplus. To that extent, we should now write down the definition according to Marshall, because today we know it according to what he said. Okay, so what is it? CS is the difference. CS is the difference between what one is willing to pay WTP and what one actually pays. So our PX, the price essentially. Okay. To acquire a particular good. This phrase willingness to pay is going to stand in the economics for a long time. Now also we use it when we talk about especially environmental economics. Okay. So what is the undertone here? The undertone is that people generally get more utility from the consumption of goods than the price they actually pay. This is a philosophical notion which is hidden in this, and to understand the implications in a broader context, we should remember this. Okay, now the traditional diagram. The diagram is probably something that you have seen in the book also. Okay, so here X, here MUX, which is equal to PX at equilibrium. So if I am drawing the demand curve, which it is, then in this demand curve, along each and every point, MUX equal to PX, and this is a very important information. Okay, so if this is PX star, the given market price, then you should consume this X star and your equilibrium Z star. Now, on each and every one of this point, MUX equal to PX. Today we call it reservation price, right? Okay. Now, first thing first, note that X starth unit does not yield any consumer surplus. Why? As MU X star is equal to PX star. Okay. So that means that CS, we can calculate CS for units below X star, and although you are paying price, let's say for this x1, price of this much, which relates to an mu value of this much, you are ready to pay this much, right? So that means this is the length that we are saving, right? Okay, and that is for 1 unit or one very small amount of x actually. And if we go along from 0 to x star, summing up all these gains, what we eventually will get is basically the definition of Dupuit, okay, which is obviously equivalent to Marshall. And remember, if these are MUs, then the area underlying this demand curve is basically giving you total utility. Okay, so this is exactly what we are going to do. For all x below x star, MUX minus PX star is consumer surplus, which is positive, and so total consumer surplus must be equal to, so integration 0 to x star mu, we should write t, not x really, then we will have a problem of a mathematical kind. So mu t minus px star dt, and if you proceed 0 to x star mu t dt minus, you can just directly write it actually px star into x star, and this here is essentially tu of the amount O x star or origin x star, and minus this is our expenditure. If we write it diagrammatically, it will give us the modern day definition of consumer surplus, which is area under the demand curve up to x star minus expenditure, that the money we spend to buy x star. Hence, as a very small result, we should write that for price greater than P star or Px star, consumer surplus reduces, and for price less than Px star, consumer surplus increases. It is this idea which is also applied when government puts certain restrictions or intervene in the market to get the desirable outcome. We will look at 5 distinct criticisms of cardinal utility theory. Obviously, number 1 is that this whole idea of cardinal number is not that meaningful. With interpersonal comparability, those are very strong assumptions actually. You cannot compare really what I feel and what you feel about the same amount of the same commodity. So 3 names we will take: Hicks, Allen who has a fantastic book of macroeconomics, and then Slutsky. So they basically rejected the cardinal concept, rejected the cardinal concept, okay, and claimed that utility is an ordinal measure. Okay. Number 2, marginal utility of money is not constant. Now, as I said, there is a long line of work on that, but if you're interested, you can look at the St. Petersburg paradox in the class of uncertainty that I have taken, and there we have discussed it, okay, Bernoulli and all that. Number 3, this additive separability, its implication is that utility of goods are independent, but utility of goods may not be independent. And the easiest example is such as complements like pen and ink. Right? Okay, number 4, we discussed within the class that it cannot explain the existence of given good or the given paradox. Now all of this is there, but the actual blow came from Edgeworth. Why? Because based on all of this, Edgeworth discarded the idea of additive separability. You may wonder why this can be such a big thing. Obviously now you can see, because this allows this, alright? So he rejected it. So he introduced the implicit form, a form of the function with which we will start the ordinal utility theory next. And here in this implicit form, as I said, here diminishing MU is neither necessary nor sufficient for convexity of IC. So now we are going to look at this whole cardinality, ordinality scene from a mathematical point of view. By that I mean that let us consider the Cobb-Douglas function. Obviously it is not additively separable. Now can I use it as a function exhibiting cardinal utility or not? Or for example, we have always stated that if I take a log of Cobb-Douglas function, then the function that we get is also an ordinal utility function. Now, does that mean that cardinality functions and ordinal utility functions are totally different? It's not like that. A function can have many properties. We say that some properties are cardinal properties and some properties are ordinal properties. So let's try to understand that. Consider any strictly increasing transformation. F maps from R to R of u of x1, x2, xn, a utility function, as a new function which is v of x1, x2, xn equal to f of u of x1 comma x2 comma dot dot comma xn, and we have said that this is a strictly increasing transfer function. Okay, so now this is what is true from a mathematical point of view. In this new utility function V, properties that remain invariant are called ordinal properties, and properties those are not preserved are called cardinal properties. So now if you go back to a rereading of ordinal utility theory, you will understand it in a much deeper meaning. Okay. So from that what we can write is that hence increasingness and quasi-concavity are ordinal properties. But the special form of utility representation are cardinal properties. That is why in the upcoming classes of ordinal utility theory, when we will be defining what a utility function is, our definition will be very, very different. Okay, it will be, as we can say it, rank preserving. But now you can go back to the ordinal utility chapter and understand that the same function can work as long as we are clear about what properties of that function we are using to measure utility. Thank you.